All right, what's up, guys? So today we're just going to be going over the solutions to all of the skill builders we've been going through, and we're going to go through 1.7 all the way up to 1.9b. All right, so let's just take a look at what we have here. So this is from 1.7a, and it's polynomial division using the box method. Right. So if we remember, when we're trying to divide using the box method, it gave us the answer, right? X cubed plus 4x squared plus x minus 6. And it told us one of the factors is x minus 1. We need to use the box method to find the other factor. So pretty much what we're saying is we're taking this function and we're dividing it by x minus 1. So how we kind of go about doing that is we know x minus 1 times something is going to give us this final answer. So we have to find what that something is. So we write x minus 1 on the side, and the top will be blank here, right? But we have the answers already. And we start with this top beginning of our function, the number with the highest exponent, and we put that in the top corner. So we have x cubed, and we got to think, okay, x times something is x cubed, so we do x times x squared to get x cubed. Then we have to do negative 1 times x squared, and we get negative x squared. Then we have to think, okay, if I'm trying to get 4x squared, what do I have to add to negative x squared to get 4x squared? And the answer to that would be 5x squared. All right, so then you go, okay, well, I know x times 5x gives me 5x squared, so I'm going to write 5x at the top here. Then I have to do negative 1 times 5x. I get negative 5x. And you got to think again, okay, going to the next one. I know my answer has positive x. What do I have to add to negative x to get positive? Or sorry, what do I have to add to negative 5x to get positive x? Well, I have to add 6x, right? And then I know x times 6 gives me 6x. And then I have to do negative 1 times 6, and I get negative 6, which is awesome because that's my last constant there anyway. So my answer then is this x squared plus 5x plus 6. All right, and number 2 is really similar if you want to take a look at that. You can pause it right here if you want to, but go ahead, take a look, and we solve it the same way. So let's keep going. All right, next is 1.7 again, right, and it's factor by grouping. So we did some of these in class, if you remember. Right, the steps are we group the first two and the last two terms in the function together, right? So we would group this 12p cubed minus 21p squared, and we'd pull out the greatest common factor of those two. In this case, it's 3p squared, and that leaves us with 4p minus 7. Then we would group the last two together, this 28p minus 49, and they both share a 7. So you pull out the 7, and that leaves you with 4p minus 7. And what happens now is this 4p minus 7, it's now the greatest common factor in both of these terms. So you can just pull that to the front, and you're left with 3p squared plus 7. Right, and it's the same process here. We group the first two and the last two together. The only big difference in this one is here the last two, right, we have this negative 21v minus 12. We pulled out a negative 3, right? And when you pull out the negative 3, it leaves you with 7v plus 4, right? So we got to be really careful about the signs. But kind of taking a look at these two, there's nothing too crazy about this one. It's pretty similar here. One big one I wanted to talk about. Well, actually, let's talk about number 4 real quick. Number 4 is a good one because you can pull out this greatest common factor of 3 first. And if you didn't do that, that's totally fine. You can still factor by grouping before pulling out the 3. You're just going to notice that at the end, you'll be able to pull out a 3 in one of these terms. All right, but let's keep going. The only other one I really want to talk about is this one. Well, and 6, I guess, is pretty similar as well. But we do the factor by grouping, right? But we notice that it leaves us with this b squared minus 16. An important thing to know about these questions, at the top it says factor each completely, right? And this b squared minus 16, that's a difference of squares. So we can factor that even more. We can rewrite that as b minus 4, b plus 4. Right? And it's the same thing here. We have this 4c squared minus 9. That's a difference of squares. So again, we have to factor that even more. Right? Just a good reminder of making sure we're always factoring completely all the way to the end. Right? Don't leave anything unfactored. But if you want to pause and check these out, feel free. But let's keep going. All right, so here we have some synthetic division. And again, I'll just run through a couple of them, and then if you want to pause for the rest of them, feel free. So here we're figuring out if r minus 3 is a factor of this function. So what it's saying is, can you divide this function by r minus 3 and get a remainder of 0? All right, so how we do that with synthetic division is we take the root, right? In this case, it's positive 3, and we write out the coefficients of the function we're dividing by, right? So we have 1r cubed, 6r squared, negative 21r, and then negative 18. We bring down the 1, then we multiply 3 times 1, we get 3. Then we add 6 plus 3 is 9. Then we go again, 3 times 9 is positive 27. Negative 21 plus 27 gives us positive 6. 3 times 6 is 18. Negative 18 plus 18 is 0. So yes, it is a factor. Right, it's the same thing in number 8. You can take a look at that if you want. Number 9, let's talk about this for a second. Now notice in the function, it skips from x to the 4th and then goes right to minus 3x squared. Right? Just because the x cubed isn't written there, we don't ignore it. We just pretend it's 0x cubed. And same thing, this goes from x squared just straight to 1. We don't ignore the fact that it's got an x, right? We just assume it's a 0 times x, which is why when we write out the coefficients, it's 1x to the 4th, it's 0x cubed minus 3x squared, 0x, and then positive 1. Right? And in this case, it gave us a remainder of negative 1, right? And if we have any remainder that's not 0, it is not a factor, right? Let's keep going. So the remainder theorem. And what this is it's saying if you want to solve a function for a certain value, you can use synthetic division, and whatever you get as the remainder is the value. All right, so when it says find f of 2 for f of x equals 3x cubed minus 2x squared plus x minus 4, and then it's also asking is x minus 2 a factor of f, we can solve both of these questions in one problem. All right, if we do synthetic division, plugging in this 2, which is also the root of x minus 2, right, we do the synthetic division just like we were doing up top, and we get a remainder of 14. What that means is that the function value at 2 is 14. And because we have a remainder, x minus 2 is not a factor. All right, so if you want to take a second, you can pause here and look at the answers for this one as well, but you all solve them the same way. So let's keep going. All right, so here is 1.7c, factoring sums and differences of cubes. All right, so for this one, remember, we're just kind of finding what is our a value, what is our b value, and then we have to plug them into those equations, right? If it's a difference of cubes, because remember, we use that SOAP method, right? It's a minus b times a squared plus a times b plus b squared. All right, because it's the same. So this would be if it was a difference, right? A minus b, that's the same, and then it's positive, which is the opposite. Then this last one is always positive. If it's a sum of cubes, it would be a plus b, a squared minus a times b plus b squared. All right, so all we have to think is, okay, for number 1, for example, we have 64x cubed. Well, I know 64x cubed. What I can do is kind of rewrite that. 64, that's the same thing as 4 to the 3rd power. And then x cubed, we would just write that as x to the 3rd power. So they're both going to be raised to the third power. And then minus 125, well, 125 is just 5 cubed. So we have our a value, we have our b value. We know we're going to be using our difference formula. So we just go a minus b, which is 4x minus 5. Then a squared is 16x squared plus a times b. So 4x times 5 is 20x. And then b squared is 5 squared, which is 25. And we do the same thing for numbers 2 and 3 as well. All right, so if you want to take a second, look at those. But let's keep going. So next would be solving quadratic inequalities. And for these, we just have to remember the steps, right? For number 4, for example, right? Step number 1 is factor the function, or sorry, step number 1 would be solving the function so that there's a 0 on one side of the inequality. Right? Then we would factor. Now this one, it already has 0, but if you look at number 5, we had to subtract this 2x squared over and the 12x, so we got a 0 on one side of the inequality. Right? Then we factor completely, and we solve each factor and setting them equal to 0. We would then plot those numbers on a number line, and we have to test a number in each interval. So we needed one before one that'll be smaller than -6, one in between -6 and -1, and then one bigger than -1. And you can test any number in those intervals. We test them by plugging them into the original inequality. All right, so here we tested -7. We got 6 is greater than 0. We know that's false, so we don't care about that interval at all. Here we tested -3. We got -6 is less than 0, which is true. So we do care about this interval. And then here we tested 0. We got 6 is less than 0, which is false. So the only interval we care about is in between -6 and 1. Sorry, -6 and -1. All right, so the domain then is from -6 to -1. And we would use parentheses here because it's just less than. It's not less than or equal to. Right, notice in number 5, it's greater than or equal to, so we have brackets around everything. All right, but we solve these the same way in each of them, so if you wanted to take a second, look at them, feel free. But I'm going to keep going. All right, so 1.8. Right, here's the skill builders. We went through the notes together, and we didn't really do any of the skill builders, but here are the solutions to them. So let's just talk about it. So for each function, identify the roots, including the multiplicity, then find supplemental points and graph each polynomial. All right, so if we want to find the roots, the first thing we're going to have to do is we're going to have to factor the function. All right, so here we have -x cubed plus x squared plus 6x. And what we notice right away is that, okay, it's got a greatest common factor, and we can pull out a -x right away. All right, when we pull out a -x, this becomes x squared minus x minus 6, which we can then factor to x plus 2, x minus 3. All right, so the roots, we have a 0 from this -x, we have a -2 from this x plus 2, and we have a positive 3 from this x minus 3. Each of them have a multiplicity of 1 because their exponents are just to the first power, which means they're all going to cross. All right, so the next thing we need to know is how is it going to look, right? What is this graph going to be shaped like? And to figure that out, we need to know the degree. So we look at the original function. It's given in standard form, so we just have to look at the biggest exponent, and it's this -x cubed, right? So it's got a degree of 3, which is odd, and it's also has a negative leading coefficient, which means it's going to have this S curve kind of shape, and it's also going to have a negative slope. Right? The last thing we need to do is find some extra points. And a big one to find is always try to find the y-intercept, which luckily for this one of the roots is the y-intercept, but if it wasn't, we would definitely want to find it. So try to get one that's like in between each of the points, right? So here we can see we have a point at -2, we have one at 0, so let's find one at x equals -1. Right here we have one at 0, we have one at 3. Let's find a couple in between there. We can find one at 1 and one at 2. And to find them, all you would have to do is plug them into your function, and you can use your calculator for that and set up a table, or you can solve it by hand. All right, but here you can see we plotted all the points. We know our end behavior, so we just have to connect the dots. Right, and it's the same in this one here, right? We factor it completely, find the roots, find the degree, find some extra points, plot, and connect the dots. And then it's the same in these as well, right? We factor, find the roots, find the degree and the leading coefficient, find extra points, and plot. Right? And this one, the only difference in this one is that it's an even degree, right? When it's an even degree, remember, it's either going to be that smiley face or that frowny face. Because it's a negative leading coefficient, we have that frowny face. Right? We have some extra points. Both of the roots have a multiplicity of 2, which means they bounce off the x-axis, right? They only touch, they don't cross. So we have the end behaviors, we have the extra points, we have the roots, we just connect the dots and plot our graph. So if you want to take a second to pause on these, feel free, but we're going to keep going. Last one. Yeah, last one, 1.9b. So in all of these, it gave you the roots and possibly the leading coefficient, and it wanted you to write out the function. All right, so if it gave us the roots, like in number 1 here, it told us the roots are at 0, -4, and +6. So we got to think, what would give us that? Well, we would have to write out the factors of the function that would give us those roots. All right, so if we have a root of 0, that means we have a factor of x. If we have a root of -4, that means we have a factor of x plus 4. If we have a root of 6, that means we have a factor of x minus 6, right? Then all we would have to do is clean it up a little bit and get it in standard form, right? So this x plus 4 times x minus 6, we can just FOIL that out, right? And we end up getting x squared minus 2x minus 24. Then we just have to multiply that x in, right? We distribute it to each term. We end up getting x cubed minus 2x squared minus 24x. Now, number 2 is really similar, but it gave us the leading coefficient, and also the roots are fractions. Right? So one way to think about roots, and one way that might make it a little bit easier for some of you guys, if we remember, we can set the roots equal to x, right? So here we have x equals 5/2. And what we can do is we can solve this so that there's a 0 on one side of the equation. Right, so I can multiply 2 over, and I get 2x equals 5. And if I want 0 on the right side of the equation, right, I can subtract 5 over. So I get 2x minus 5 is equal to 0, which tells me that this root of 5/2 gives me a factor of 2x minus 5. And I can do the same thing here with this -8/3. It's going to give me a factor of 3x plus 8. I also have a leading coefficient of -4. And then once I have it written like this, I just have to FOIL it out, right? So I do 2x times 3x, I get 6x squared. I do 8 times 2x, I get 16x. I do -5 times 3x, I get -15x. And I do -5 times 8, I get -40. You clean that up, and we get this right here. Then you just have to distribute the -4 in. And end up with -24x squared minus 4x plus 160. All right, so number 3 and number 4 and even number 5, they're a little bit different because it tells us the leading coefficient and it tells us the root, but we have to remember a couple things. For instance, we have a root of the square root of 2. And if we remember, we have this thing called the irrational roots theorem. Whenever you have an irrational root, we also have the opposite of it. So if we have a square root of 2, we're also going to have a negative square root of 2. So we just add that into our factors, right? Once we have all of them written out, we just follow the same procedure, right? So we're going to FOIL this x minus square root 2, x plus square root 2. And it ends up cleaning up and becoming x squared minus 2. Right, then we FOIL the x minus 7 and x squared minus 2, and then you just have to distribute the 5. Right, so we get this answer here. Now it's the same in number 4, right? We have this 1 plus square root 3. Because it's a square root 3, we also have to have 1 minus square root 3. And once we have that all written out, right, we just add these into our roots. So the root of 1 gives us a factor of x minus 1. The root of 1 plus square root of 3 gives us a factor of x minus 1 plus the square root of 3. And then this 1 minus square root of 3 gives us a factor of x minus 1 minus the square root of 3. Right, so we can then clean this up. Remember, this minus is going to distribute into the parentheses here. So this becomes x minus 1 minus the square root of 3. And same thing here. This becomes x minus 1 plus the square root of 3. Right, then to FOIL this, all we would have to do is make sure we multiply each of the terms in this set of parentheses with each of the terms in this set of parentheses. So we do x times x, we get x squared. We do x times negative 1, we get negative x. We do x times the square root of 3, we get square root of 3 times x. Then we have negative 1 times x, we get negative x. Negative 1 times negative 1 gives us positive 1. Negative square root 3, negative 1 times positive square root 3 gives us negative square root 3. Then we have negative square root 3 times x gives us negative root 3x. Negative root 3 times negative 1 gives us positive root 3. And then negative root 3 times positive root 3 gives us negative 3. Right, and we can just clean that up. Then we'll have to do that one more time when we distribute this x minus 1 into the problem. We end up getting x cubed minus 3x squared plus 2. And then the last one, number 5, right, it gave us a root of I and 4i. And that just, we have to remember with that, right, that's the complex conjugate roots theorem. If we have imaginary numbers, we also have to have the opposite of them, right? So if we have I, we're also going to have negative I. If we have 4i, we're also going to have negative 4i. Right? And we just write those out as our factors. Right? We can FOIL this x minus I times x plus I, and it cleans up pretty nicely. And we can also FOIL this x minus 4i and x plus 4i, and it also cleans up nicely. Remember, when we have I squared, I is just the square root of negative 1. So if we have I squared, we just have negative 1. All right, so we can clean it up a little bit more, and you end up getting 2x to the 4th plus 34x squared plus 32. And that is all of the skill builders. If you have any questions, feel free to reach out. Remember, you can always watch this over again, pause at different points, and just let us know if you need anything. Great job today, guys.